You know that moment when you spend hours building the perfect base, only to watch everything collapse like a house of cards because of a single miscalculation? Yeah, I've felt that pain too. In All Will Fall, physics is unforgiving, and gravity is your worst enemy. After seeing my own megastructures crumble more times than I'd care to admit, I decided to test the limits of the game's mechanics. Today, I'm going to share 10 engineering secrets I learned the hard way to create an absolutely indestructible fortress. Grab your tools, because we're going to build something that simply never falls. I'm Matthew, and the video starts now. If you've experienced the frustration of seeing your megastructure collapse out of nowhere, you probably made the same mistake I did at the start, relying too much on external walls to hold the weight of your construction. And look, I get it. Visually, it makes sense. The walls are at the edge. They look robust. They look like they're holding everything up. But the game doesn't work that way. And once you learn the difference, everything changes. The most important rule I learned is the central core. The game has a physics system that distributes vertical load in a very specific way. And what it wants to see is a continuous skeleton running from the top to the ground, passing through the center of the structure. This core needs to be made of high-density materials, and ideally it should consist of elevators, stairs, and pillars that never break that vertical line. Think of it as building a spine for your city. When you place this core in the center and ensure it touches the ground, the game engine recognizes this load path and distributes weight much more efficiently throughout the entire structure. I've tried placing isolated pillars on the edges thinking it would solve the problem, and it doesn't. What the game truly rewards is this vertical continuity in the center, no interruptions, no detours. If you break this line at any point, stress begins to accumulate silently until everything falls at once. External walls serve an aesthetic and protective role, but do not rely on them to hold the weight of multiple stacked floors. They can and will fail under high pressure, especially when a storm arrives or the water level changes and the base terrain recalculates the support points. Your central core needs to be so robust that even if the entire periphery of your construction collapses, the core remains standing. That is the right mindset for scaling a real megastructure in All Will Fall. You've probably seen your structure looking perfect, resisting the weight, with a solid central core, and then a lateral wind comes along and knocks everything down like a house of cards. This happens because there is a type of force that most people completely ignore when building an All Will Fall shear force. It doesn't push from top to bottom. It pushes from the side, and square walls simply weren't made to handle that. The solution is truss triangulation, and it's simpler than it looks. You use the rotation command to position beams diagonally on your floors, forming an X pattern, the famous X bracing, that civil engineers use in real-world skyscrapers. This detail completely transforms how the game's physics engine processes the forces acting on your structure. Instead of letting the lateral shear force travel through the wall until it breaks, the diagonal redirects that force and converts it into compression, which is exactly the type of load the game handles much better. Think of it this way. When wind hits a straight wall from the side, it bends and collapses because it has no way to dissipate that energy. But when you put a diagonal there, the force has to choose a path, and the only path available is compression along the beam. And the physics engine in All Will Fall was clearly designed to accept compression much more stably than pure shear. This isn't a bug, it's a real physical behavior that the game simulates with surprising fidelity. Best of all, you don't need to do this on every floor of your megastructure. Focus mainly on the service floors, which are the most exposed to the wind and where horizontal forces are most intense. Place X bracing at these critical points, and you'll notice your construction begins to withstand storms that previously knocked everything down in seconds. Combine this with a strong central core, and you have the foundation of a megastructure that truly does not fall. This one is one of the trickiest tips because the problem doesn't appear immediately. You finish building your megastructure, place all the generators on one side because it was more convenient at the time, put the refineries in the same block to simplify logistics, and the structure seems to be standing, stable, and working. But it's tilting. Silently, millimeter by millimeter, and by the time you notice, it's too late. The game actively monitors your construction's center of gravity And this is something that surprises many people. It's not just the total weight that matters, it's where that weight is distributed. If one side of your structure is about 15% heavier than the other, the physics engine begins to calculate a progressive tilt that accumulates over time. Heavy machinery like generators and refineries have significant mass in the system, and stacking everything in a single block is basically a guarantee that you'll have a structural collapse with no obvious cause. The fix is simple in theory, but requires discipline when building. Whenever you place a heavy machine on one side, mirror the weight on the other side. It doesn't have to be the same machine, it can be another structure of equivalent mass, but balance must exist. Think of your layout as a scale. The central core we talked about earlier is the pivot, and both sides need to weigh roughly the same so the scale doesn't tip in any direction. What makes this problem particularly cruel is that the collapse rarely happens the moment you finish building. It comes later, after the game has processed several physics cycles and the accumulated tilt finally hits the critical point. So, if your structure collapsed out of nowhere after hours of operation, mass imbalance was likely responsible. Treat load symmetry as a non-negotiable rule from the first floor, not as something you'll fix later, because in all will fall, later usually doesn't exist. If you've ever seen a tower collapse in a matter of seconds without any apparent warning, no strong wind, no mass imbalance, nothing, it's likely that the center of gravity of your construction shifted outside the perimeter of the base. And when that happens, the game doesn't give you a second chance. The collapse is instantaneous, total, and painful, especially after hours of building that structure. The pyramidal scaling rule exists specifically to avoid this nightmare. The logic is straightforward. The base of your megastructure needs to be at least 30% wider than the top. It sounds like a lot, but as you start stacking floors and adding machines, tanks, and platforms, the center of gravity rises and shifts in ways you can't predict just by looking. The only reliable way to ensure that this center of gravity always falls within the perimeter of the base is to have a base generous enough to absorb any variation. The reference I like to use to visualize this is the Burj Khalifa. It isn't a straight rectangle from the ground to the top. It tapers as it rises, creating a shape that intuitively looks more stable, and it is. The game rewards exactly this logic. A straight tower might seem more space efficient, but it is constantly at the limit of what the physics engine accepts, and any addition of weight on the upper floors could be the final straw that sends everything down. So change your mindset before you start building. Don't think tower, think pyramid. Plant a wide base, keep it well anchored to the ground with your pillars and central core, and taper it gradually as you go up. You'll lose some space on the lower floors, but you'll gain stability that no other isolated technique can deliver. Combine pyramidal scaling with the central core, X-bracing, and load symmetry, and your megastructure will remain standing while everything else on the map collapses. Sometimes, the best thing you can do for your megastructure is to build parts of it intended to break. Not out of carelessness or lack of resources, but completely intentionally. Because when a strong storm hits or an explosion happens near your base, something is going to give. The question is what you want to give way first. This is where the logic of sacrificial layers comes in. The idea is simple. You surround your central core and the entire primary structure with a layer of lightweight, cheap materials like aluminum scaffolding around the outer edges. These materials aren't there to hold anything up. They are there to die in the right place. When an impact occurs, the game's physics engine processes the energy of that collision, and if there are weaker structures in the way, they absorb that energy first before it reaches the main core. Think of it like the crumple zone technology in modern cars. The central chassis is rigid and protected, but the ends of the car are designed to crumple and absorb the impact before it reaches the driver. In All Will Fall, it works the same way. Debris falling from upper floors, shockwaves from explosions, or the accumulated pressure of a long storm will all hit your sacrificial layer before they reach what really matters. And since these materials are cheap, you can rebuild the periphery without losing what took hours to construct. The big mistake I see is people putting their best materials everywhere uniformly, thinking that more strength at every point is always better. But strength costs resources, and resources in All Will Fall are limited. When you understand that you can direct fragility strategically, you start building in a completely different way. An armored central core X-bracing on critical floors, a well-planted pyramidal base, and a sacrificial edge around it to absorb external chaos. That is the architecture of a megastructure that the game simply cannot knock down. If there's one thing I've learned, it's that the game does not forgive those in a hurry. And the most classic mistake practically everyone makes at the beginning is exactly the same. Looking at that tiny structure down there and thinking, I'm going to go up now. I want to see this grow fast. But I need to warn you, if you do that, your construction will collapse. Not maybe, it will. The golden rule here is simple. Expand sideways before anything else. All Will Fall has a real physics system applied to every beam, platform, and pillar you place. This means each new structure you stack up there adds weight and direct stress to the base. A narrow tower has no way to distribute that weight efficiently, and the game's physics will collect that error from you with interest. On the other hand, a wide base divides that load among multiple support points simultaneously. Think with me, it's exactly how real engineering works. A skyscraper doesn't start by being tall, it starts by being solid and wide. The broader your foundation, the greater your margin for error when you finally decide to go up. And in All Will Fall, margin for error is literally the difference between your city prospering or watching everything crumble in slow motion while your colonists look at you with disappointment. So before you add any more floors to the top, answer me honestly, have you expanded horizontally enough? The game gives you a warning timer before a structure collapses for good. And that's generosity on the developer's part. Use that time to reinforce the base, widen the sides, and distribute the weight. A wide base isn't just a nice tip. It's the only reason a megastructure in this flooded world can survive. Players have documented builds with over 15 floors in sandbox mode, and none of them got there by starting with the roof. Look, I know the urge is to just keep building nonstop, placing floor after floor, and watching your megastructure grow. I understand that feeling, but All Will Fall has a tool that most people ignore completely in the first few minutes of the game, which honestly should be turned on all the time from the second you place your first beam on the ground. I'm talking about the stress overlay. What this tool does is simple yet devastatingly efficient. It shows you in real time where your construction is accumulating load. The color logic is straight to the point. Healthy structure, cool color, structure under high pressure, yellow. Structure about to give you a lesson in humility, red. And the game isn't joking when something turns red. It's literally telling you, reinforce this now or lose everything. Every floor you add, every bridge, every heavy building you fit into the structure redistributes weight in a way you can't predict just by looking. But the stress overlay can. The mistake I see most often is this. A player builds everything excitedly, then only activates the overlay once they notice something is wrong, and by then, half the base is already screaming in red. At that point, fixing it becomes a complicated surgical task. The difference between those who use the overlay before every new addition and those who use it after is huge. You transform the construction process into a calculated decision instead of a gamble. So here is the habit you need to develop before placing anything new on your megastructure. Activate the stress overlay first, analyze the colors. If it's clear, proceed. If it's yellow, think twice. If it's red, stop everything and reinforce. It's this simple cycle that separates the towers that reach the top from those that become a slow motion disaster scene as your colonists fall with them. All Will Fall is generous enough to give you this information on screen. Use it. There's an illusion that All Will Fall creates in you during the first few hours of the game. Everything seems stable, your structure is growing, the colonists are happy, and you start to think you've understood the system. Then you add one more floor without placing robust pillars underneath, without any lateral reinforcement, and in a matter of seconds, you watch your megastructure fold in the middle like a soaked matchstick. This specific moment is the game telling you, without any ceremony, that you still haven't learned the most basic rule of vertical construction. Robust pillars exist for a very clear function, to absorb vertical load. Every floor you stack adds downward weight. And without pillars sized to handle that weight, the structure will yield at the weakest point it finds. But here is the detail many people don't realize right away. Vertical load isn't the only problem. Wind, weight imbalance, and the construction's own geometry create horizontal tension. This is exactly where lateral trusses come in. They lock the structure from the side, prevent it from swaying, and distribute that horizontal tension in a way that no single pillar can do. Think of the two elements together as a partnership. The pillar holds what is above, the truss holds what is to the side. Without the two working together, you have a structure that looks firm, but is constantly at war with itself. And in All Will Fall, this war always has one winner: physics. Not you. The rule of thumb is this: before going up any new floor, pillars and trusses must already be in place. Not after, not in a bit when I have resources. Before. Treat these two elements as mandatory prerequisites for any vertical expansion, without exception. The megastructures that don't fall in this game aren't the result of luck or trial and error. They are the result of someone who understood that pillars and trusses are engineering decorations. They are the reason the whole thing is still standing. In structural engineering, there is a concept called load redistribution. When a section of a structure experiences pressure beyond its limit, the weight has to go somewhere. If the surrounding elements are connected, that excess is distributed among them and the system holds. If they aren't, that section collapses alone and pulls the rest down with it. All Will Fall simulates exactly this. And the ground floor is where this logic begins or ends. Most people set up the ground level in an improvised way. They place a platform here, another there, leave spaces between them, and build upwards without thinking much about what's underneath. The problem is that every loose platform on the ground level is an isolated island. When weight from above starts pressing on a specific point on the ground, that island has nowhere to send the overload. It simply breaks. And when the ground floor breaks, it doesn't matter how much you reinforce the upper floors, what has no foundation won't stay up. So the solution is to form a grid. Interconnect all the ground platforms, creating a continuous grid with no gaps between elements. When you do this, the ground level begins to function as a single organism rather than separate pieces. The load from an overloaded section automatically migrates to its neighbors, the stress is diluted over a much larger area, and the structure gains a resilience that no vertical reinforcement can replace. I like to think of the ground floor of a megastructure as the foundation for everything that comes after. And in All Will Fall, that is, before you think about anything going up, look down at the ground and ask, are my platforms all connected, forming a solid grid? If the answer is no, the rest of the planning doesn't matter much. Fix the ground floor first. Everything above will thank you. In All Will Fall, concentrating tons of weight on a single support point isn't a strategy, it's a countdown. You don't know when, but you know it will fall. The concept that changes everything here is called the load path, the path that weight travels from the highest point of your structure down to the ground. When you funnel all that load through a single pillar or central column, you create a bottleneck. All the weight of your megastructure passes through that specific point, and that point has to handle absolutely everything alone. The game has a physics system that calculates this accumulation in real time. And an overloaded central pillar doesn't give much warning before giving way. It simply gives way. The solution isn't even complicated. Distribute. Multiple pillars spread across the base create multiple paths for the load to descend to the ground. When weight has path options, it divides naturally between them. If one pillar starts accumulating more than it should, the neighbors absorb part of that pressure. You move from a fragile system where a single point of failure destroys everything to a robust system where the partial failure of one element doesn't compromise the whole. The mindset you need to develop in All Will Fall is one of suspicion toward anything that seems to rely too much on a single element. Do you see that your construction is being supported mainly by one column? That's a red flag, not a sign of efficiency. Add pillars, redistribute the load path, and spread the weight across more contact points with the ground. Megastructures that don't fall don't have a single hero holding everything up. They have an entire team sharing the weight.